It's you and me, 11.5, scale factor. All right, so we've done scale factor before, so we're going to repeat it, but we're going to have actual theorems to go with it. All right, so if I give you two shapes, these look like they are similar octagons. I want you to find the ratio of their sides. So you basically compare their sides. Scale factor is 6 to 16. Now it depends on how I ask you. If I say go from small to big, then you have to go from small to big. If I say left to right, then go left to right. I think the homework wants you to go left to right. Sometimes I might say from green to brown, then you have to go from green to brown. But you have to follow the directions. In this case, we're going to go from left to right. Um, one of the sides is 6. You compare it to the other side, which is 16. That is the scale factor, but you always have to reduce. Reduce it down to 3 over 8. All right, so that was just comparing the sides. What if I said find the ratios of the perimeters? So then you would have to find the perimeter of the small one. Since this is a regular octagon, all the sides are the same. So it's just 6 times 8, and then 16 times 8. 48 over 128. But again, we always have to reduce it. 3 over 8. Look at that. The scale factor for the sides is the same as the scale factors for the perimeters. That is actually always going to be true for similar shapes. All right, so whatever the scale factor is for the sides, it's also going to be the scale factor for the perimeter. So we didn't actually have to find the perimeter, we can just use this rule. What about area? What if I asked you to find the scale factor for the two areas? Do you think it's going to also be 3 over 8? That will be incorrect. It is not going to be 3 over 8. What do you think it's going to be? It's actually going to be 3 squared over 8 squared. And that kind of makes sense because, you know, all of our units for area is units squared. So you have to square those numbers. And that's actually 9 over 64. All right, so that's how you find the scale factor for area without having to actually find the area. And here's the official theorem, the areas of similar polygons theorem. If two polygons are similar with the corresponding sides of a ratio of a to b, then the ratio of their areas is a squared b squared. All right, so let's go ahead and do a few examples. Find the scale factor of their sides. All right, so now you have a few choices. You can use this side compared to this side, or you can do this side compared to this side. Both will get you the same answer, but you obviously want to choose the easier one without the decimal. So let's go ahead and do the 35 over 5. Reduce it down to 7 over 1. To find the perimeter scale factor, it's always going to be exactly the same, 7 to 1. And then the scale factor for the area, you square it, 49 to 1. All right, so not too bad. Let's do another one. Find the scale factor of the sides. This one, you actually don't have a choice. You have to use the decimal, 2.6 over 4. But in mathematics, you are not allowed to have a fraction and a decimal in the same answer. So how do you change the decimal so it's no longer a decimal? What you do is you move that decimal one place over. And if you move it one place over on top, you have to move it one place over on the bottom. It becomes 26 over 40. Reduce it, and there you have it, 13 over 20. The scale factors for the perimeter Also 13 over 20. Perimeter is always the same. But the scale factor for the area, you have to square those numbers. 169 over 400. All right. Let's do some examples where you actually have to find the area. So this problem gives you the big triangle with base 15, the small triangle with base 9, and they tell you the area of the big one. You have to find the area of the small one. All right, so there's no real formula to do this without using that property. Before we do this problem, let's go ahead and list out all the scale factors. We'll do the side scale factor, which is 15 over 9. Reduce it is 5 over 3. The perimeter scale factor, same, 5 over 3. And then the area scale factor, 25 over 9. Which one of those scale factors do you think you're going to have to use to find this area? Obviously, the area scale factor. There's the setup. There's the area scale factor, and then this is what we're trying to look for. Now, the important part here is to be consistent. If you're going to go from the green triangle to the brown triangle or orange triangle, then you have to be consistent throughout the whole problem. Otherwise, you'll mess up. I went from left to right, and so I'm going to continue to go from left to right throughout the whole problem. Cross multiply and solve. The area of the small one is 54 inches squared. All right. Last one for the day. Going backwards. What if they give you the areas and you have to go backwards to find the sides? All right. So in this case, they give you the area scale factor, 125 over 45, reduces down to 25 over 9. Ooh, but how do you go from there backwards to get these two guys? You square root. Square rooting 25 over 9 is 5 over 3. Square rooting it is 5 over 3. So you're going to actually use the side scale factor to set up the problem. 5 over 3 equals x over 35. Cross multiply and divide. And there you have it. Scale factors. Go ahead and try the homework.